Now let's take a look at this unit, and we'll skip over some of these topics because I think they're self-explanatory or you've seen them before. Plot points on a rectangular coordinate system, but let's go down to use the distance and midpoint formula. Now, given 2 points, x1, y1, and x2, y2, we have the distance formula, which says d is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. We also have the midpoint formula, it says our midpoint is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So if we have the points 3, negative 1 and 4, negative 2, and I want to find distance. Now, first thing I want to do is label these. This is my first point, so I'll label this as x1, y1. This is my second point, so I'll label this as x2, y2. Now for our distance, I'm going to go through and replace all of my variables with sets of parentheses. Same thing with the x's. And then we'll plug in what we identified. We said y2 is negative 2. We said y1 is negative 1. We said x2 is 4. And we said x1 is 3. So then we got negative 2. Negative negative gives me a positive 1 squared plus 4 minus 3 is 1 squared. Negative 2 plus 1 is negative 1 squared plus 1 squared is 1. Negative 1 squared is 1, so we got 1 plus 1 or the square root of 2. Now it is possible after you get down to this point you'll either plug it in your calculator and find out a decimal approximation, or you'll simplify it to find an exact answer. This one you can't simplify, but if you end up with square root of 12, then you could have went down further. Now our midpoint. Midpoint, typically you don't need to put any extra parentheses in there. It's a lot easier formula. You add together your x parts. So we got 3 plus 4, then you divide by 2. And you add together your y parts. Negative 1, negative 2, divide by 2. 3 plus 4 is 7, so we got 7 halves, and negative 1, negative 2 is negative 3. So we got negative 3 halves. So that'd be our midpoint. And this is our distance. Now, next topic is graphing equations by plotting points. Let me clear this off. Let's say I have y is equal to x squared minus 3. We want to build a t-chart, and you plug in values. Well, plug in negative 1, 0, and 1. For x equals negative 1, we'll plug that in to our equation. So we've got y is equal to negative 1 squared minus 3. Negative 1 squared is 1 minus 3. So that gives us negative 2. Now we'll plug in x equals 0 into our equation. So we're going to have y is equal to 0 squared minus 3, which gives us negative 3. Now we'll plug in x equals 1. So we've got y is equal to 1 squared minus 3. 1 minus 3, or negative 2. Now we got negative 1, negative 2, which is right there. We got 0, negative 3, which is right here. And we got 1, negative 2, which is right here. Now it really doesn't give us enough idea of what's happening to come up with the graph. So what we'll do is we'll plug in a couple more points. We'll put in 2 and negative 2. Okay, so let's plug in 2 in the original equation. So we've got y is equal to 2 squared minus 3. 2 squared is 4, so we've got 4 minus 3, or 1. Now if I plug in negative 2, I'm going to have y is equal to negative 2 squared minus 3, which is 4 minus 3, or 1. Okay, so we've got 2, 1, and we've got negative 2, 1. Okay, now I'm starting to see the pattern here. Looks like our graph is looking like this right here. How many points do you need to pick? I have no clue. It depends upon the graph you're looking at. In some cases, you may find 2 is enough, perhaps 3. But in other cases, you might have to do 7 or 8 until you get the actual picture of the graph. So it's kind of a clumsy way to come up with a graph. The best way that this method works is if you already know what it looks like before you begin. Now think what I'm saying there. Why are you even graphing it then? So let me clear that off. Now identifying x and y intercepts. Down here they got determine x and y intercept of a function. And so I'll explore this a little bit further. But just identifying the x and y intercept, if you're looking at it graphically, I won't show any examples of this, but the x-intercept, this is where the graph crosses or touches the x-axis. And y-intercept is where the graph crosses or touches the y-axis. So you just visually look at it and you can see what the intercepts are. You know, actually, since we're already on this topic, let me go a little bit further. And say I got 2x plus 4y is equal to 12. Now I want to find the intercepts. So finding the x-intercept. Step 1, plug 0 in for y and solve. Now finding the y-intercept. Step 1, plug 0 in for x and solve. It's always the same. Whenever you find the intercepts, you always plug 0 in for the other variable and then you solve. Doesn't matter whether we're doing linear, quadratic, or whatever, that holds true. So here, to find the x-intercept, our first step, we're going to plug 0 in for y. So we got 2x plus 4 times 0 is equal to 12. 4 times 0 drops away. We got 2x equals 12. Divide both sides by 2. And you get x is equal to 6. So this point here would be 6, 0. Now our y-intercept. And I didn't put step 2 down here. Step 2 is where we're solving. Step 1, plug 0 in for the other variable. So plug 0 in for x. So I got 2 times 0 plus 4y is equal to 12. And then solve. 2 times 0 drops away. So we got 4y is equal to 12. Divide both sides by 4. And you get y is equal to 3. So this would be 0, 3. Now in some questions you may just be asked to find the intercept, and that's it. In other ones you may want to use the intercepts to graph it. And really the only time that ever works out well is when you have a line. When I say a line, everything's the first power, like this problem. So if our instructions were to graph this, let's show how we would then go on. We got 6, 0. So I'll put a point there. Then we got 0, 3. And I go put a point there. And then you draw a straight line through the intercepts. And that'd be your graph. If you're plotting if you're using plotting points and you're graphing a line, then this actually works out fairly well. Maybe better than other methods. Okay, let me clear that off. Graphing equations using a graphing utility. I'm going to graph the basic building blocks. As soon as this comes up. Ignore what you're seeing here. This is left over from another class. Okay. Let's take a look at graphing. Y is equal to x. And I know some of these would be pretty easy and you don't need to use calculator for them. Press my y equals. Press my clear. That clears out whatever's on the line. And then I'll push my x key. This one right here. Now it doesn't do anything exciting, just puts x on there. When I say x key, see how it says x, t, theta, little n? That's too hard to say or to write, so I always just say x key. And then graph. And that'd be our graph. Sometimes you get errors when that pops up. One of two things. If you go to the y equals, you shouldn't have plot 1, plot 2, or plot 3 highlighted. So if you have one of them highlighted, like it'll look like that, what you need to do is unhighlight it. So you do an up arrow, put your flashing cursor on whichever one's highlighted. You may have to do your right arrow key to go to the right, and then you press enter one time, and you'll see the highlighting go off of it. Now, one of three things that happen if you have those highlighted. One, it'll work just like normal. One, it'll put extra boxes on your screen, and one of them you get an invalid dim. And then the second thing is if you do zoom and choose 6, that sets back to your standard viewing window. Now those will probably fix about 97, 98% of the problems you have. If you have other ones, you just contact me. Now y is equal to x squared. Press our y equals, clear. I'll do my x key, and now I'll push the x squared button. This x squared button doesn't put the x on there for you. All it does is put the squared. And then graph. And then it'll look like that. Now y is equal to x to the third. If I press y equals, press clear, I do my x key, caret 3. Caret is how you do a power. If you got one of the near T84s, you have to press your right arrow key to get it out of the exponent mode. And then graph. Although you don't have to do a right arrow key on this particular problem, but other more complicated problems you would have to do it. Now, y is equal to x to 1/2. The trick here is anytime you have more than a single number or a single variable or single anything in your exponent, you have to put parentheses around it. So when we plug this in, we have to put parentheses around the 1/2. So press my y equals, press my clear, do my x key, caret, beginning parentheses, 1 divided by 2, and closing parentheses, and then graph. Now if you got square root of x, you press your y equals, press clear. Now it's above the x squared, so to get to it you have to do your second button and then the x squared. And it puts a square root on there for you, and if you do x key and graph, then it'll give you your graph. Happens to actually give us the same graph as the previous problem, which they should, because that's just another way of writing the square root of x. Cube root of x. Now press my y equals, press my clear, press the math button, and we want to choose the cube root, which looks like number 4. So I do 4, and I'll put x in, and then graph. And that would be our graph of the cube root, as well as I can draw it. Now, when you got any number in a slot, 4, 5, 6, or whatever, let's take a look at how to handle that. You press your y equals, clear. You put your index, that number in a slot, in first. I'll put in 4. Then I'll choose math, and then I'll choose number 5. That one looks like a radical with an x for the index. Then I'll do a beginning parentheses, x, and then closing parentheses, and then graph. Looks like square root, but it's just a little bit closer down to the x-axis. It'll look like that. And one last basic function we'll take a look at is the absolute value of x. So I press my y equals, press my clear, I go to math, then I right arrow to num, and ABS is our first one. So I do enter on ABS, put my x key in, and I put graph. And that gives us our V-shaped graph. As well as I can draw a V. Now that's graphing equations using a graphing utility. So let's go on to the next section. 2.2, circles. And it says, write an equation of a circle in standard form. So let's talk about that. We got circles, we got something called standard form. And that's x minus h squared plus y minus k squared is equal to r squared. Now if you have it in that form, then your center is going to be hk, and your radius is going to be r. Now it's a little bit vague on what they mean by this. Write an equation of a circle in standard form. The assumption here is that we're given a graph. It doesn't specifically say that, but from the graph we've identified the center. Let's say the center is 3, -2. And we've identified the radius. Radius is distance from the center out to the outer edge. Let's say that's 4. Now if you have these, you can identify your hk and r. So our center is going to be h, so h is 3, and then k, so k is -2. And our radius is our r, so r is equal to 4. Now after you've identified those, you just plug them into your standard form. So I got x minus h is 3 squared, plus y minus k was -2 squared, equals r squared, so that's 4 squared. So I got x minus 3 squared plus y plus 2 squared is equal to 16. And that'd be our standard form. Now the other topic here says write the general form of an equation of a circle. Well, this is standard form. General form is where it's of the form and there's different variations of this, and to be honest, I'm not quite sure which one this book chooses. But you have x squared plus y squared plus ax plus by plus c is equal to 0. Or you just have to see this stuff, and there'll be different variables on these. But you'll have ax squared and then plus ay squared plus bx plus cy plus d equals 0. In order for it to be a circle, they have to have the same numbers in front of them if they're in this form. Well, let's go ahead and get rid of the parentheses. So x going a step further. So we got x minus 3 squared, which is x minus 3 times x minus 3. We got y plus 2 squared, so I got y plus 2 times y plus 2. X times x is x squared, x times negative 3 is negative 3x. Negative 3 times x is negative 3x, and negative 3 times negative 3 is 9. Plus y times y is y squared, y times 2 is 2y, 2 times y is 2y, 2 times 2 is 4, equals 16. So we got x squared plus y squared. Put those next to each other. Negative 3x is negative 6x. Then the y's. 2y plus 2y is 4y. And we got 9 plus 4, which is 13. And I'll bring the 16 over. And we end up with x squared plus y squared minus 6x plus 4y minus 3 is equal to 0. I said there's different variations of this. Some books will tell you there cannot be any number in front of the x squared and y squared. On the other hand, some books tell you that you cannot have any fractions here, that everything has to be an integer. And so it depends upon which book you look at and which form they choose. I've even seen one book that had this c, this number, over on the right side. But anyway, that's our general form. Now section 2.3 gets into functions, so let's talk about those. Function says for every x there is only one y. An easier definition of function says if you have one of the following, it is not a function. If you have y to an even power, if you have the absolute value of y, if you got the plus or minus symbol, or you got x is equal to a number, like x is equal to 3, for example. I'm not sure what that green was, but so if I had a problem, let me clear this off. If I had a problem look like this. Y squared is equal to 3 plus x. And the question is whether it's a function or not. The fact that it has y to an even power means the answer here is no, it's not a function. On the other hand, if I had y is equal to x to the fifth minus x squared plus 3, we don't have y to an even power, so that's good. We don't have the absolute value of y, so that's good. We don't have this plus or minus symbol, so that's good. And we don't have x is equal to a number. If you had x equal to a number, it would say x equals 3 or x equals 5. Nothing else with it. So the answer here is yes, this is a function. Now we have something called a vertical line test. And this says if any vertical line intersects a graph at 2 or more places, then it is not a function. For example, if I had this graph right here, and you're wondering if it's a function or not. If I can draw a vertical line that intersects at 2 or more places, it's not a function. Well, this is violated right there. I just drew a vertical line that intersects at 2 or more places. So the answer here would be no. On the other hand, if I had this problem right here, if I draw a vertical line one place, draw a vertical line one place, draw a vertical line one place, you notice that there's no place I can draw a vertical line where it doesn't intersect at, where it intersects at 2 or more places. So the answer here is yes, this is a function. Now we got something called function notation. And our function notation has two purposes. First one is to give it a name. What do I mean by that? Well, if you had y is equal to 3x plus 5, and you had y is equal to 4x minus 7. If I told you to graph y, well, your question would be, well, which one? There's two y's. It's kind of like naming your two children the same name. So instead of calling it by y, we instead give it a name. Not like Bill or Bob, but a name looks like this. This is read as f of x, or we even get lazier math, we just say f. The other one, we give it a different name. And this is read as g of x, or we could simply say g. Now these have no mathematical meaning. That does not mean f times x, does not mean g times x. They're strictly names. That's his first purpose. Second purpose is to simplify writing, or reduce writing, sorry, not simplify. For example, if I had evaluate, I had this example here, evaluate y is equal to 3x minus 1 for y when x is equal to 5. Well, what we do if we're doing this is we'd go through and replace all of our x's with parentheses and plug into 5. So we'd have y is equal to 3 times 5 minus 1, 15 minus 1, or y is equal to 14. Well, instead of writing it that way, we could say f of x is equal to 3x minus 1, and say find f of 5. So that notation right there says the same thing as all those words. It's still calculated the same way. We'll go replace all of our variables with sets of parentheses, and we'll plug in whatever we're evaluating for. So 15 minus 1 is 14. Now let me actually write down our steps for evaluating a function. Step 1, replace all parentheses with all variables with sets of parentheses. Step 2, plug in whatever we are evaluating for into the parentheses. And step 3 is to simplify. So I'm going to clear this off. And say I got f of x is equal to x squared minus 3x plus 1. And we're wanting to find f of negative 1. Step 1. Replace all variables with sets of parentheses. So I got parentheses squared minus 3 times parentheses plus 1. Step 2. Plug in whatever we're evaluating for into the parentheses. Now it's always the same. Whatever's inside the parentheses right here is automatically what we put in right here and right here. So put negative 1 there and negative 1 there. Negative 1 squared is 1. Negative 3 times negative 1 is positive 3 plus 1. And 1 plus 3 plus 1 gives us 5. Now you could have something that looks like this. F of x equals 3x minus 1. We want to find f of x minus 5. Yeah, step 1 is still the same way. And I didn't do step 3 here. Step 3 is simplify. Step 1 is go through, replace all of the variables with sets of parentheses. Everything else remains exactly the same. Step 2, plug in whatever we're evaluating for into the parentheses. Whatever's inside the parentheses here is now we're going to put inside the parentheses over here. And that would be x minus 5. And then step 3 is to simplify. Here we use the distributive property. 3 times x is 3x. 3 times negative 5 is negative 15 minus 1, which gives us 3x minus 16. And that's our answer. Let's see, apply function notation. We talked about x and y intercepts. Domain and range of a function. Interpret a function graphically. And like I said, some of this I'm not gonna cover. Now the next topic is dealing with lines. So let's talk about lines. Let me grab a drink here. We have something called a slope. That says given 2 points, x1, y1, and x2, y2, your slope is y2 minus y1 over x2 minus x1. So if we're given 2 points, negative 3, negative 5, and 2, negative 7, and want to find the slope between them, of the line segment that passes through them. Now, this is our first point, so let's identify this. This will be x1, y1. This is our second point, so this will be x2, y2. It's always a good idea to go through, replace all of your variables with sets of parentheses. So I got parentheses minus parentheses over parentheses minus parentheses. Now y2 we said was negative 7 and y1 is negative 5. x2 is 2 and x1 is negative 3. So we got negative 7, negative negative becomes a positive 5. And negative negative here becomes positive, so we got 2 plus 3. So that gives us negative 2 over 5. And that'd be our answer. Okay, let me clear that off. Now we have something called slope-intercept form. And you could use function notation if you want, or y. So you could have f of x or y is equal to mx plus b. Now if it's in this form, where you got f of x or y by itself on this side, and x the first power, then whatever number's in front of your x is going to be your slope. Whatever number's at the end is going to be your y-intercept. Now graphing linear equations in two variables, I won't show that, but you could plot points if you wanted to. Determine the slope of a line, we just did that. Apply the slope-intercept form of a line. I'm guessing what they mean there is you can actually graph using that. And that's actually a pretty easy way if you don't have a graphing calculator. If I have, for example, y is equal to 1/3 x minus 2. Our slope will be whatever number's in front of our x, which is 1/3. Now, the slope, this is a change in y, so that's up and down. It's positive 1, so that means we'll go up 1. This is the change in right and left, and it's positive 3, so that means we'll go right 3. Now, if I was graphing this, our y-intercept is a number at the end, the negative 2. So I go put a point at my y-intercept, and from there I use the slope to find my second point. So I go up 1, right 3. So up 1, right 3, and that's where I put my second point. And then you draw a line through them. If you miss your point, just draw the point a little bit bigger. And that'd be our graph. And then we'll get down to here talking about the point-slope formula, although I don't use that. I have a different way of working those problems. If my instructions are to finding the equation of the line. Step 1. Step 1 is to find m. Step 2, plug in m from step 1 and the given point for x and y, and solve for b. And then step 3 is to write the answer. Plug in m from step 1 and b from step 2 into y equals mx plus b. So if I am given 2 points, like 2, 3, and -5, -7, and the instructions are to find the equation line. First step is to find m. Well, we've already looked at a formula for finding m given 2 points. So this will be x1, y1. This will be x2, y2. And our slope is y2 minus y1 over x2 minus x1. So y2 is -7, y1 is 3, x2 is -5, and x1 is 2. So we got -7, -3 gives us -10. -5, -2 gives us -7. So I'll give us 10/7. Negatives cancel. Step 2. Plug in m from step 1, which we said was 10/7, and a given point for x and y. We're given 2 points. It doesn't matter which one you pick. I'll pick the first one. Plug this in for x and plug this in for y. So I got 3, and then x is 2 plus b. And then we want to solve for b. 10 times 2 is 20, so we got 27ths plus b. Take 27ths to the left side, becomes a negative 27ths. Now, I'm going to use a mixed number rule here. 3 times 7 is 21, plus a negative 20 gives us 1/7 equals b. And then step 3. Plug in m from step 1, which is 10/7. So we got y is equal to 10/7 x, and b from step 2, which is 1/7. And that would be your answer. Y is equal to 10/7 x plus 1/7. Now it's talking about parallel and perpendicular lines. And specifically it says to find the slopes, but we're going to combine that with find the equation of the line. So let me clear this off. So finding the equation of the line given a point and a parallel line. Step 1, find m. First substep within that is to write the given line in slope-intercept form. Step 2, identify the slope. Step 3, parallel lines have the same slope, so m is going to equal to, and I'll come back to that, blank. Step 2, plug in m from step 1c and the given point for x and y into y equals mx plus b and solve for b. And step 3 is to write the answer. Plug in m from step 1c and b from step 2 into y equals mx plus b. Okay, so if I had a problem, it says passing through the point -2, -1, and it's parallel to y is equal to 3x minus 5. Step 1, find slope. First substep is to write the given line in slope-intercept form. Well, this is already written in slope-intercept form. Y is already by itself. Our second substep, it says to identify the slope. Now the reason why we put it in slope-intercept form is so we can easily see what our slope is. Slope is whatever's in front of your x, so slope is 3. Now parallel lines have the same slope. So we said it's parallel to this line. We said the slope of that line is 3. And since they have the same slope, then our m we're trying to find will be 3. Step 2, plug in the slope from 1c, which is 3, and the given point for x and y. Remember, this is x and this is y. So I got -1 over there, x is -2 plus b, and then solve for b. So 3 times -2 is -6. Take -6 over, becomes a positive 6. And -1 plus 6 is 5, so we got b is equal to 5. Then step 3, plug in m. M was 3. And plug in b, which we said was 5. So we got y is equal to 3x plus 5. It's pretty strange how close those are. Now let's find an equation of a line given a point in a parallel line. Let's say you have a perpendicular line. And perpendicular lines have slopes that are negative reciprocals. So and we'll come back to that. But other than that, all the other instructions are the same. We'll clear this off. And let's say I have the point negative 5, 1, and it's perpendicular to 5x plus 2y is equal to 3. Okay, step 1. Want to find m. First sub-step is to write the given line in slope-intercept form. So we want to solve for y. So I take the 5x, move it over. So I got 2y is equal to negative 5x plus 3. Divide everything by 2, and we got y is equal to negative 5 halves x plus 3 halves. Now the slope. Slope is negative 5 halves, whatever number's in front of our x, assuming this is in slope-intercept form. Now, perpendicular lines have slopes that are negative reciprocals. So, we're going to start with the slope from 1b, which is negative 5 halves. We're going to write it in fraction form. Now this is already a fraction, so we're fine there. But if it wasn't, like if I had the number 5, you would put 5 over 1. You can always create a fraction by putting it over 1. And then we're going to flip it. This is a reciprocal part. Reciprocal means fraction flipped. And then we're going to change its sign. So it goes from a negative 2/5 to a positive 2/5. And that's what a negative reciprocal means. Means flip the fraction, change the sign. So the m we're trying to find is going to be 2/5. So then step 2. Plug in the x and y. This is x and this is y. So we got 1 equals m, which is 2/5, times x, which is negative 5, plus b. Now this 5 is going to cancel, so we got negative 2 plus b. Take negative 2 over, becomes a positive 2. And we get b is equal to 3. And then step 3, write down our answer. So we'll plug in m, which was 2/5. So we got y is equal to 2/5 x, and b, which said was 3. And that'd be our answer. And yeah, I'm probably gonna stop there. I got videos on these other topics, and we'll leave time for any questions you might have.